So what's duplex sequencing? It's a sequencing method that's ultra-sensitive in detecting mutations that's present at a very low level. Let's say at the beginning of a cancer, there are just a few cancer cells living among a vast amount of normal cells. When you want to detect them, you have to take the DNA from all of them, and the mutations that's from the cancer cells are going to be buried with the vast amount of normal DNA from normal cells. So having a test that can detect those very low levels of mutations will enable early detection of cancer, which they introduce early intervention. So why is duplex sequencing so sensitive? Before we go to the explanation, let me take a moment to say hello. Welcome to Dr. XY's channel, where you will hear fun facts and useful information about genetics from a board-certified clinical laboratory geneticist. In a previous video, I promised that I'm going to explain what duplexing sequencing is on a later day, and today is the day. So why is duplex sequencing so sensitive? Let's imagine our DNA from each cell like a book. As we age or as cancer develops, unfortunately, the book starts to accumulate mistakes in them. Say it starts to have a word missing or duplicated or replaced here and there, and we want to find them. So in order to find them, now you decide you're going to gather 10,000 books and use a software to read them aloud. And the software itself has an error rate, say 1 in 1,000, just hypothetically. The traditional sequencing method is like reading each book from the beginning to the end, while duplex sequencing method is like reading each book from the beginning to the end and then backward from end to the beginning. So for the traditional sequencing method, when you say detect mistakes in 1 to 2 books out of the 10,000, you cannot say for sure if those mistakes are true mistakes from the books or if they were introduced by this reading software. So the traditional sequencing method, it's not that it cannot detect, it cannot spot the low-level mutations at all. The problem is that it cannot distinguish that from the background noise that's intrinsic to the assay itself. In contrast to that, duplex sequencing, because it reads the books from the beginning to the end and then from the end back to the beginning, when you detect a mistake that's at the same place of the book, in both occasions, then you can be pretty confident that this mistake is most likely a mistake from the book. So the background noise of duplex sequencing is virtually zero. Therefore, any low-level mutation can be readily detectable. This is very important for early cancer detection, as I alluded to earlier and in a previous video. So does that mean we should replace all genetic testing with duplex sequencing? No. As I explained in depth in a previous video, genetic testing is like hide and seek. Depending on what we're looking for, we would choose different sample types as well as different test methods. So that's it for today. I looked up duplex sequencing on Wikipedia, where there is a decent explanation, but it's noted as too technical for most people to understand. So how do you think my explanation is? Feel free to share a comment below. All the videos I mentioned today are linked in the description below. If you find today's information helpful and useful, like, share, and subscribe. Thank you so much for visiting, and I will see you next time.